Right. So like Jason, I'm a computer scientist. So Jason uses prefix algorithmic to describe what I do, what he does. I use computational. I think we basically refer to the same thing. Right, so before I start describing what I mean by my area, I'd like to mention that my own background is in mathematics, and that didn't prevent me from doing a PhD in computer science and now working in a computer science department. Right, so if your own background is mathematics, this is good for computer science, this is good for game theory, I think. Right, also if your background is economics and computer science, I think these are all excellent starting points. Okay, so what do I mean by computational social choice? Computational social choice, I think of it as a subfield of algorithmic game theory, so whatever Jason said remains relevant. So more specifically, so what do we study? If I had to answer in one sentence, it would be algorithmic aspects of collective decision making. So let me unpack a little bit. Collective decision making, that the non-computer science part, the more general part, is how groups of people can make collective decisions. What kind of collective decisions? Voting would be one example. Group of people get together, make a joint decision that impacts them all. So another example would be coalition formation, large group of people splitting into smaller groups because they want to interact in these smaller groups just socially, or maybe because they want to implement projects at these smaller groups. Fair division would be yet another example. People have a resource to divide, could be a single divisible resource, money could be indivisible, different indivisible resources, inheritance. People decide what is the right, appropriate, fair way to split that. Okay, so what are the algorithmic computational aspects? Well, all these problems I mentioned are problems we actually want to solve in practical scenarios, and for them to be solvable in practical scenarios, we need to be able to do it quickly and with a reasonable amount of communication. So the sort of questions that computer scientists tend to ask in this context is, okay, here's a good solution concept, here's a desirable property, can you have an efficient procedure that implements this idea? Efficient in the technical meaning of computer science. Polynomial time algorithm with a lower running time. So when it looks to be impossible, we tend to prove formal complexity results, NP hardness results are similar. We also tend to look at communication. We also tend to use frameworks from computer science, approximation algorithms, randomized algorithms. Right, so collective decision making is a classic topic. Algorithmic computational perspective brings, I think, a new angle. So to illustrate, let me talk about one specific topic, kind of just as an illustration, where I feel that my field had some impact. Participatory budgeting is something that I think is also taking off in Morocco and happens now for real in many places around the world. Right, so this is the situation where citizens, residents of a kind of country, neighborhood, need to choose among projects to implement to make the area better. So examples of projects would be new playground, improving a homeless animal shelter, contributing to training of firemen, or communal garden. So these are all real projects from around the world. So there's a small budget, we're not talking the entire local council budget, but a small amount of money to be spent on these activities, right? And each project, of course, has a cost, right? So as you can see, these projects can be very different in cost. So there are costs, there's budget, right? So people vote, people say which of these projects they like more, which projects they like less. There can be different ballot formats. And the goal is then to make a decision which of these projects to implement given the budget constraint. Right, so as you can see, this is a voting problem, but this is perhaps a more complex voting problem than just electing a president or even electing a government body because of the cost aspect. Okay, so how can we computational social choice theorists contribute to this problem? Well, there are different things we can do. We can study existing voting rules, and there's a variety of voting rules out there. So we can say, okay, this rule is good, this rule is bad. We can try to quantify how they're good and bad, right? So we can try to propose efficient algorithms for implementing these rules. More interestingly, though, we can try to design new voting rules. How would we go about designing new voting rules, and why would we want to design new voting rules? Well, a principled way of going about that is to formulate what is it that you want to accomplish when you run participatory budgeting, right? And then come up with a rule that is, okay, in the order of importance, I think, actually produces good outcomes, then is feasible to implement in practice, computationally feasible in particular, and also isn't too hard to explain to the voters, makes sense to the electorate. I think all these are important. Okay, now zooming in on good outcomes. right? So this is something where we need classic social choice to help us. How do we formulate what is a good outcome, right? So how do we capture this idea? So this is typically done by axioms, right? And then our job would be to devise voting rules that satisfy these axioms. Okay, so this is a long journey. I think kind of to keep the presentation short, I will go through this very quickly. So there's been several attempts in the literature to formulate what is a good outcome, right? And those were mostly the idea of fairness to groups. As an individual voter, you're not entitled to a project that you like, but maybe there's a group of voters that all want similar thing, right? So then the desires of that group should be followed to some extent. We can't have an entire large group that likes a particular project to remain completely unrepresented. And okay, there were several attempts to capture that using ideas from the literature. One classic idea from economics literature is the concept of the core, which unfortunately turns out you can't over-satisfy. Sometimes the concept of the core is, well, sometimes the core is empty. There are no solutions that satisfy the core. There's been attempts by computer scientists to devise approximation algorithms, find outcomes that are approximately in the core, but I would say that they haven't led to practical algorithms. So what another line of research that has been attempted, right, and that happened more in the computational social choice community, was to simplify the problem and look at the instance with unit costs, right? Unit costs are simple because then you know how many projects you want to implement, right? So each project has unit cost, you have a budget K, so you're implementing K projects, right? And then it just becomes conceptually easier to think about it. And in fact, there was an existing strand of research in multi-winner voting that tried to capture the idea of fairness, right? And within that line of research, there was an axiom called extended justified representation, which I'm not going to explain, but which was effectively a relaxation of the core, and unlike the core, it was always implementable, right? So that offered a useful starting point, right? And now let me give you a timeline. 2015 was the year when the extended justified representation axiom was proposed in the multi-winner voting literature. And at that time, so the axiom was proposed, but there was no voting rule that would satisfy that axiom and was efficiently computable. Right, so even with the focus on that simpler multi-winner voting scenario, it took a while, well, not a very long while, but it took 3 years for the community to come up with the first proof of concept result, a voting rule that we as computer scientists liked, right, in the sense that it satisfied this axiom we had in mind, and it was efficiently implementable. Right, it didn't satisfy this last desideratum of being practical, so that took another year of coming up with a rule that was computationally efficient, satisfied the good axiom, and was also something they could explain to voters. That was called method of equal shares. It took another year to extend it from multi-winner voting to participatory budgeting, right, and it took 2 more years. Right, but if you think about it, that's 8 years from the axiom to practical implementation. It took 2 more years to implement that method in practice, right? And now there are places around the world where this idea that sort of starts from a very theoretical perspective on voting to get implemented, right? So currently there are 3 cities in the world that use this new method of equal shares, and the new method of equal shares was in fact kind of, it came not so much by people directly trying to design a good voting rule. It came from people thinking about axioms and way to satisfy them in a computationally efficient manner. Okay, so this is 8 years from theory to practice, right? And I think if you ask people in this room how long it typically takes from theory to practice, I think it's a big win, right? So this is one, okay, so maybe I'm overselling my field, right? But this is a proof of concept that sometimes in this field, you can go from theoretical ideas to something useful and practical very quickly. Something else I wanted to mention is that this is, in a way, young people's game, right? So the 2 people who proposed method of equal shares, right? So this is Piotr on the left and Dominic on the right. So Dominic is a CNRS researcher. So they got their PhDs within the last 10 years, right? So Dominic was, in fact, my PhD student, right? So it doesn't take to be an established senior researcher to come up with useful new ideas and to implement them. Right, and an even younger person in the middle, Simon Ray, University of Amsterdam, who just got his PhD a few months ago. Right, so he's in fact going to move from academia to not so much industry, but to the local city council to actually work on the implementation of participatory budgeting ideas. Right, so that's one way to move from academia to real world and continue to do what you did for a PhD research. Okay, and before I conclude, right, so this was kind of about my research area specifically. Kind of one general point of PhD studies. PhD studies take you places, right? Especially if you do a PhD in computer science, you tend to publish in conferences. Conferences take places in locations around the world, right? So these are pictures I took traveling to conferences in 2023. Okay, so I can't promise you the same as a first-year PhD student, right? But slightly more seriously, if you stay in academia, this is a very good way to get exposed to the broader world, to see the world, to meet people from around the world, maybe to live in different places if you are so inclined, right? So PhD is a very international affair, right? So if this is something that you like, if you have a taste of adventure, I recommend that. Thanks.